BN350 was a sodium-cooled fast breeder reactor designed to produce approximately 700 megawatts of thermal energy. Construction was started in the late 1960s. The plant first produced electricity in 1973 and was permanently shut down in the year 1999. The plant was designed to produce both steam for electricity and process steam, which in turn was used to desalinate water from the Caspian Sea. Following the shutdown of the reactor, oil and gas-fueled thermal power stations were built to fill the void. By design, the fast breeder reactor also produces weapons-grade plutonium of the highest quality. When the reactor was shut down, there were approximately 300 metric tons of spent nuclear fuel elements containing both plutonium and highly enriched uranium. Starting in the late 1990s, a campaign was undertaken to place all of the spent nuclear fuel elements into special-built canisters. This work was completed in the early 2000s. Thus, Phase 1 of the project was completed. Phase 2 of the project was to load the spent nuclear fuel-containing canisters into long-term storage and transportation casks and transport these casks from Aktau in the far west of Kazakhstan to the new long-term high-security storage location in northeast part of Kazakhstan. This was accomplished using both rail and road transportation. The process of loading the casks with spent nuclear fuel canisters started by moving an empty cask onto the purpose-built cask transfer rail car. This took place at the temporary spent nuclear fuel storage pad. The cask and transfer car were then transported to the BN350 reactor building for loading. The loading of the canisters into the cask started by first removing the outer seal plate, next the outer lid, then the inner lid. Once the lids were removed, the internals of the cask were exposed. The cask is divided into 8 canister storage cells. Once the spent nuclear fuel elements had been sealed in storage canisters, the canisters were then placed into baskets in the spent fuel pool. This underwater storage provided biological shielding as well as thermal cooling. Some of the canisters had remained underwater for more than 10 years. As a result, it was required that a check for leak tightness be conducted. This involved placing the canister in the shielded canister conditioning station, drilling a hole, conducting canister conditioning, and then resealing the canister by welding a plug in the drill bore. All 479 canisters were found to have maintained leak tightness. With the canister having completed conditioning, it is then moved to the cask. All of this work is performed using cameras and remotely operated overhead cranes. The skill required to move the canister and precisely insert it into the cask required extensive training. Once all 8 canisters were seated in the cask, closer operations commenced. When the inner and outer lids are sealed, the cask is checked for leak tightness and backfilled with an inert gas. The upper seal plate is then seated and welded. The cask was then transferred back to the temporary spent nuclear fuel storage pad, where it was stored until it was time for rail transport. The transportation overpacks consist of a base plate and a cover. Their purpose is to provide the cask with additional protection during the rail and road transportation phases. The casks are seated on the base plate and the cover is lowered into position. The two pieces are bolted together and locking pins secure the cask in place. This nominal 110-ton assembly is then inverted 90 degrees and placed on the purpose-built rail cars. A total of 60 casks were filled with spent nuclear fuel and transported via rail and road. 5 casks were transferred for each shipment. With the departure of the 60th cask, use of the temporary spent nuclear fuel storage pad was complete. Once the train cars were assembled, the train departed Aktau for the 3,000-kilometer journey to its destination. The trip took approximately 4 days. Upon reaching its destination, the transportation overpack with the cask were offloaded into special-built multi-wheel transporters for the final 70-kilometer journey by road.
Oh, there is a level.
When the transporter arrived at the long-term storage pad, the overpack containing the cask was offloaded. The overpack cover was removed, and the cask was removed from the base plate and set on the pad. A gathering of dignitaries from the government of Kazakhstan, United Kingdom, and the United States of America arrived to commemorate the occasion of the placement of the 60th and final cask. With this accomplished, the technical aspects of Phase 2 were completed.